So children, I am going to explain in this video about the properties of solids. And properties of solids have been classified into the following categories: electrical, then semiconducting, then there is the magnetic. And so first I am going to start with the electrical properties. So children, electrical properties means the behavior of a solid, behavior of a solid with current, behavior of a solid with the current. So this is the basic point about this. Now on this electrical property, the solids have been classified into three categories. First is the conductors. Second is insulators, and third is semiconductors. So there are three categories: conductors, insulators, and semiconductors. Insulators and semiconductors. Now I am going to explain about the three. And so children, the solids have been classified into three categories by a theory, by a concept called a band theory. It is band theory. So band theory explains that the solids have two bands. Solids have two bands. Bands means the certain area, certain prescribed regions in which there is the flow of electrons takes place. And so band theory suggests that every solid has two bands. Number one, valence band. Number two, conduction band. Now, conduction band is the outermost. It is the outermost, and this valence bond, it is inside or just attached. It is just attached to conduction band. It is just attached to conduction band, and so this is the basic. So now I am going to explain how the three classes of the solids on this conduction band theory is there. So first I am drawing about the conductors. So in the conductors, they are all metals, and so in conductors we have this type of condition. Here, this is the first condition, and here there is the second condition. See how they differ from each other. The outermost, it is conduction band. It is conduction band, and this is valence band. Conduction band and valence band. So electrons, you have a previous knowledge, electrons are present in the valence band. And so it is actually a new concept to explain the difference in the insulators, conductors and semiconductors. So when this is the second condition. Now in first condition, the valence band and conduction band, they just touch each other. This is the first, they touch each other, and this is the second way, and here there is the overlapping. There is a overlapping of the valence band and conduction band, and children know that whenever little amount of current is passed, the metals, they act as conductors. So this is the about 1 point. So where little amount of fluid is there, and so they act as good conductors. So the difference of the different metals, you know about the resistance. Different metals like iron, it has more resistance. Copper and silver, they are best conductors because there is no overlapping. There is no overlapping, and as a result, we have this theory. This is so about the conductors. Now coming to second part about the insulators. So in case of insulators, children, the gap is very large, and there is separate area. This is the what? This is the valence band. This is the conduction band, and so in insulators the gap is very large. Gap is very large, and in any case the electrons from valence band, they can never be transferred to the conduction band, and as a result they do not allow the flow of current. Plastics, rubber, dry wood, stones, they all are insulators because the gap is very large between the conduction band, and it is also called as forbidden zone. This is also called as forbidden. It is also called as forbidden zone. So gap is very large, and so in any case insulators cannot be converted to conductors, etc. Now children, the third portion is semiconductors, and so about the semiconductors. Semiconductors, they lie between this conductors and insulators. So very little amount of energy is required. So example, silicon, germanium, these are two main semiconductors, and how they have been made as per the band theory. So there is very small gap. This is the conduction band. This is conduction band, and here there is very little gap. This is the valence band, and as a result very little amount of energy required. So very little gap is there. Silicon chips, they are used to prepare solar photovoltaic cells, and so silicon and germanium, they are called as intrinsic semiconductors. Intrinsic semiconductor means by default they have the tendency to allow the flow of current, and so when very little amount of sunlight or light falls on silicon chips or germanium chips, they start allowing the flow of current, and so they act as conductor. So this is about the basic point about this. Now I am going to explain this very important part, children, the classification of semiconductors. And so semiconductors, they have been divided into two categories. They are of two types. First is N-type, N-type semiconductor, N-type semiconductors, and second is P-type semiconductors. N-type and P-type semiconductors, and this N stands for negative charge carrier. Here negative particle act as charge carrier, and here P stands for positive charge carrier, and here P stands for hole also. So here hole means there is the vacancy. Now, as you know, pure silicon and pure germanium, they are called as intrinsic semiconductors, and so N-type and P-type semiconductors, N and P-type are called as extrinsic. They are called as extrinsic semiconductors. Extrinsic. This is very important to know. So extrinsic means they are made by adding some impurities. And so how they are made? So children, next point is doping. So doping is addition of very small amount of impurities in intrinsic semiconductor. So doping is mixing very small amount of impurities in intrinsic semiconductors. Intrinsic semiconductors, mixing of very small amount of impurities is called as this doping. Mixing of very small amount of impurities in pure silicon or germanium, it is called as doping. So it is mixed in micrograms. Now see, N-type semiconductor is obtained by mixing or doping group 15 member in silicon or germanium. P-type is obtained by mixing group 13 member. Group 13, here group 15. So group 13 you know, aluminium. Group 15 is phosphorus. And so how it is there? So in normal condition, here see children, here there is the silicon, and silicon you know atomic number is 14 and 4 electrons in outermost orbit. So there is the joining with the phosphorus group 15. So here there is the phosphorus. See how phosphorus, one electron is extra. One electron is extra. So here there is the bond. There is the bond, and so this extra electron. So if there is here more silicon, here will be more silicon, here will be more silicon. So here there will be 4 silicon atoms are attached, and so there is formation of the 4 covalent bonds. But this electron is extra, and so this is called as N-type semiconductor. Now coming to aluminium, like this aluminium. So aluminium, here I am drawing, and here we have the silicon, and so silicon it is. So here there is the covalent bond. Now other silicon, this is the bond. Let me complete. Here there is the fourth silicon atom. So this bond, it is electron deficient children. This is electron deficient bond, and it is nothing but it is hole. So here there is deficiency of positive charge, and that's why it is called as p-type semiconductor. So this is all about the basic points